Hello, my name is Simon Goodwin. I'm an astronomer at the University of Sheffield, and the main thing I'm interested in really is how stars form, and also when stars form, planets also form straight afterwards. So really why I'm here at Granada is to find out what Gaia can tell us about how stars form and how planets form. The big debate we've been having this week really is it's not clear at all to us how stars form. We know that there are big clouds of gas, and those big clouds of gas form stars, and the stars tend to form in groups. So the sun is pretty much on its own. The nearest star to the sun is about 4 light years away. Whereas when we look around us at very, very young stars, we tend to find that they're in groups of hundreds, thousands, even hundreds of thousands of stars, all packed within about the space from us to the nearest star. And this is really interesting because when planets and when solar systems like our own are trying to form, it means they're forming in an environment where there are lots and lots of other stars nearby. We think these can affect how planets form, these will affect how stars form. When we look at these places, most stars seem to be in binary or triple systems, so not one star like the sun, but 2 or even 3 stars. Then because they're in these sorts of environments, a lot of these get broken up, so there's questions about, did the sun start with a companion, which it then lost? Did the sun start somewhere that was a lot less dense than where we see most stars form? And so is our solar system unusual? Now, the trouble with doing this is it's incredibly difficult physics. How stars actually form from the gas is really difficult, and we really don't understand it. So the wonderful thing that Gaia is going to do, and I think it is an absolutely fantastic instrument, is it's going to allow us to look at stars when they're a few million years old. For astronomers, that's incredibly young. So they form, it takes them maybe 100,000, 200,000 years to form, and then they move around within the gas, and the gas disappears after a couple of million years. And that's the point where Gaia can look at them. And so what we can use is Gaia's going to find exactly where stars are, and also it's going to see where they're moving. So if we can see young stars, then we can actually trace them back and find out where they came from and how they were distributed and how dense they were. And we can see what the normal sort of environment for a planet is, for a star is, and also what the normal sort of environment for forming planets is. Because it's not at all clear. Star clusters, where you get hundreds, thousands, tens of thousands of stars, are easy to find. They're all very, very close together, they're very bright, there's some very, very massive stars, so those are really easy to find. So we know about those, but we're not entirely sure whether they're the most common place where stars form. It might be that many, many stars form in what we call associations. So again, there's maybe hundreds, maybe thousands of stars, but a lot more spread out. And these disperse very, very quickly, and then you just can't see them. And what Gaia is going to do is it's going to look out to huge distances and tell us exactly where stars are. So what we can do is look for the young stars, trace them back, and see where it was they formed. And then this tells us what star formation must give us, and also Gaia is going to find planets. So we can look at these things and we see, are they in binary systems, are they in multiple systems, do they have planets, do planets look different in different places? And hopefully this is going to be really, really good at giving us clues to where solar systems like our own came from, how common is our solar system and our sun, and ultimately really what are the chances of finding life like us somewhere else in the galaxy and in the universe.